Want to help us understand how we can graph something called an inequality. And we might be familiar with what an inequality is. So say, for example, I have x is less than 3. That's an inequality. Tells me that all my values that are less than 3 make this true. 2 is less than 3, 0 is less than 3, negative 67 is less than 3. So to find out or to communicate all those solutions, because there's a lot of them, it'll be easier to graph them out on a number line to demonstrate what all of our solutions look like. So the best way to do that is draw a number line, find the pivot point if the equation has one. This one, it's 3. Something happens at 3. So I'm just going to mark 3 on my number line. I know zeros and negative numbers to my left, positive numbers to my right, as it happens on out. So this one describes this is true for all values of x greater than 3. Or sorry, all values of x less than 3. So I know all these values are true over here. So I'm going to shade in all those values. And then I'm also going to kind of communicate it in some type of a way that those values go on out forever. So always, but what happens at 3? Well, this is where we need to be careful. 3 is not a solution to this particular inequality. So I need to draw a line as close to 3 without touching it, which is very difficult to do. So we have two different types of ways that we can describe that. One way is that we can put a little bit of a circle on 3. Tells me all my solutions up until 3 are solutions. Another way you might see it being communicated is you'll see a bracket kind of put on it, kind of a soft parentheses bracket that kind of collects all the values and stops just shy of 3. So there's one way that you can describe the solution to this particular inequality. Let's try another one here. Let's look at all x's greater than or equal to negative 1. How would we graph that one out? Well, let's draw our number line. What's the pivot point? The pivot point or the change of directions happens at negative 1. So let's put negative 1 on our number line just to give us a frame of reference. From here then, I'm looking for all my solutions which are greater than negative 1. So I'm going to shade in everything that's greater than negative 1 and maybe make a little bit of an arrow that way just to communicate that my solutions continue on out forever. Going back towards negative 1, or as x approaches negative 1, I have to decide what happens at negative 1. Well, in this case, my inequality includes negative 1. So I'm going to put a circle or a dot on negative 1 to communicate negative 1 is a solution. Or, rather than a soft bracket, I'm going to put a hard bracket right there at negative 1 to collect all my solutions. And the hard bracket includes negative 1 as its solution. Lastly, another example I might want to show is I have negative 1 is less than x, which is less than or equal to 3. Have a compound inequality. We can graph that just as well. Draw a number line. Look for our pivot point. But this one has two pivot points, negative 1 and 3. So I'll put negative 1 somewhere. I'll put 3 in a relatively correct spot. And then I'll determine where my solutions are at. This one says all my solutions are greater than negative 1, but less than 3. So I'm going to shade all those things in between those points, then determine what happens at negative 1. Do you remember? Negative 1 is not a solution, so because of that, you'll put a soft bracket at that point. At 3, is 3 a solution to this inequality? It is. So I'll put a hard bracket at that particular point. So that's how we can graphically decide what the solutions are at. And it's a lot better way than trying to list out all the numbers that makes that true. Graph it, draw a picture.